Hi everyone, my name is Athira, and today we're going to be talking about solving systems of nonlinear equations. So you've probably already worked on systems of linear equations, but now we're going to explore systems where at least one equation is nonlinear, such as quadratic, circles, and other curves. And so we're going to walk through this step by step using examples, and by the end, hopefully you'll have a solid understanding. So let's get started. The first thing that we're going to talk about is what is a nonlinear system of equations. So a system of nonlinear equations is just like any system of equations, except one or more of the equations are nonlinear. So let's start with an example. So if we have this system where the first equation is y equals x squared plus 2x minus 4, and the second equation is y equals 2x plus 5, we can see that this first equation here is quadratic, and we can see that the second equation here is linear. And so the intersection of a quadratic and a linear equation can have 0, 1, or 2 solutions depending on how the line intersects the parabola. And that's what these three drawings here are showing you. In this first drawing here, we can see that the line doesn't intersect the parabola, and so we would say this has 0 solutions. And in this drawing here, we can see that the line intersects the parabola at exactly 1 point. And so we can say that this has one solution. And in this last drawing here, we can see that the line intersects the parabola at 2 points. And so this system of equations would have 2 solutions. So one way you can solve a system of nonlinear equations is by graphing. So let's try this method with an example. So let's take, for example, equation 1 is going to be y equals x squared minus 2x minus 1, and equation 2 is going to be y equals negative 2x minus 1. So let's start off by graphing this linear equation here. So we know that the y-intercept is going to be at 0, negative 1, because when x equals 0, y is negative 1. And now we can just plug in some values for x and figure out what the y is. So when x equals 1, y is going to be equal to negative 3. And when x equals negative 1, y is going to be equal to 1. So now those are some points we can plot on our graph. So we have 1, negative 3, and negative 1, 1. And y is 0 when x equals negative 1/2. So that's another point we can plot right here. So this is what our line looks like. Something like that. And now we can start graphing the quadratic equation. So here we know that the y-intercept is going to be also at 0, negative 1, because when x equals 0, y is going to be equal to negative 1. And we can also find the vertex. And so the vertex is going to be at, if the x-coordinate is given by negative b over 2a, we can see that the x-coordinate of the vertex is going to be negative 2 over 2 times 1. And so that's going to be 2 over 2, which is just 1. And now we can plug in this x-coordinate back into the quadratic in order to find its y value. So we'll have 1 squared minus 2 times 1 minus 1, which is just 1, minus 2 minus 1, which is just negative 2. And so the vertex of the parabola is going to be here. And we also know, because of the axis of symmetry, that 2, negative 1 is also a point. Let's plug in one more point so that we can graph our parabola. So let's graph negative 1, x equals negative 1. So when x equals negative 1, y is going to be given by this equation. So we'd get 1 plus 2 minus 1, which is 3 minus 1, which is 2. So we get negative 1 comma 2. So that's also a point on the parabola. And so now we can graph this. We can say that the parabola is going to look something like this. And now we can see that the line and the parabola intersect at exactly one point, which is right here. And so the solution to this equation is just 0, negative 1. Okay, so next we're going to look at solving by substitution. So this involves solving one equation for one variable and substituting it into the other equation. So let's look at an example. Let's say we have a system of equations where the first equation is x squared plus x minus y equals negative 1, and the second equation is x plus y equals 4. So the first thing that we can do is we can solve the second equation here for y. In order to do that, we can subtract x from both sides, and we'll get y equals 4 minus x, which can also be rewritten as y equals negative x plus 4. The next thing that we can do is we can substitute negative x plus 4 into the first equation. So the first equation is x squared plus x minus y equals negative 1. And now we can substitute negative x plus 4 for y. And we'll get x squared plus x minus negative x plus 4 equals negative 1. So I'm going to distribute this negative here, and then we can add like terms after that. So once we distribute the negative, we'll get x squared plus x minus 4 equals negative 1. Once we add like terms, we can add this x and x here. We can get x squared plus 2x minus 4 equals negative 1. And now we can add 1 to both sides. If we add 1 to both sides, this right-hand side is going to be equal to 0, and then we can factor. So let's see what this equals. This is going to equal x squared plus 2x. Negative 4 plus 1 is just negative 3. And this is going to be equal to 0. And now we can factor this equation. So x squared plus 2x minus 3 can be rewritten as x plus 3 times x minus 1. We can see that 3 times negative 1 will equal to negative 3, and 3 plus negative 1 is equal to 2. So now we can see the solutions for the equation are x equals negative 3 and x equals 1. Now we can substitute back to find y. So let's see. If we have x plus y equals 4, we have x plus y equals 4, and x is negative 3, then we can say negative 3 plus y equals 4, and we can add 3 to both sides. So y equals 7. And we can also say that x plus y equals 4 for x equals 1. And so this can be rewritten as 1 plus y equals 4. You subtract 1 from both sides, and you'll get y equals to 3. So the 2 points where the quadratic and the line intersect are going to be at 1 the 1 here and 3 here, 1 comma 3, and what we got up here, which is negative 3 comma 7. So that's going to be our answer. Okay, now let's look at solving systems by elimination. So this method works well when you're adding or subtracting the equations cancels out one of the variables. So let's take an example. So let's take this system where the first equation is 2x squared minus 5x minus y equals negative 2. And the second system is x squared plus 2x plus y equals 0. Now, if you look at this equation, you can see that if you add them together, this negative y here and this positive y are going to cancel out because negative y plus y is just going to be 0. So let's add these two equations together. So we know that negative y plus y cancels out, so this is just going to be plus 0 here. 2x squared plus x squared is 3x squared. And minus 5x plus 2x is negative 3x. And this is going to be equal to negative 2 plus 0, which is just negative 2. Now we can bring this negative 2 to the other side by adding 2 to both sides. And that's because we can get this right-hand side equal to 0. So we're going to have 3x squared minus 3x plus 2 equals 0. Now we can find the solutions to these equations by using the quadratic formula. The quadratic formula is just x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So in this equation we have, if we look at this equation, a equals 3, b equals negative 3, and c equals 2. So now we can plug in these numbers into the quadratic formula. So x is going to be equal to negative b, negative times negative 3 is just 6, plus or minus the square root of b squared. B squared is negative 3 squared, which is 9, minus 4 times a, which is 3, times c, which is 2, all over 2 times a. 2 times a is just 2 times 3, which is 6. Now, if we look inside the square root here, we can see the square root is going to come out to 9 minus 4 times 3 is 12, 12 times 2 is 24, so 9 minus 24. So what's inside the square root is going to be a negative number, and that's not a real number. It's going to be an imaginary number. And so we can say that because what's inside the square root is going to be imaginary, this system of equations has no real solutions. Okay, so the last thing we're going to go through is graphing systems with circles. So let's look at an equation of a circle. An equation of a circle is just given by x squared plus y squared equals r squared. And this circle is going to have its center at 0, 0, at 0, 0, and its radius is going to be equal to r, so the square root of r squared. So if we have x squared plus y squared equals 16, then we're going to have a circle that's centered here at 0, 0 and has a radius of 4. Now we can solve a system of nonlinear equations by graphing. If you have, for example, a linear equation and a graph or an equation of a circle, and you want to find out the points where they intersect. So a line can intersect a circle like that, or like that, where it's just at one point, or it can intersect a circle like that, where you can see it intersects at 2 points. So we can solve a system of equations where one equation is the equation of a circle by graphing. So let's take, for example, the first equation is going to be x squared plus y squared equals 25, and 2y equals negative x plus 5. So let's graph this. If we graph it, we'll have that. Let's graph the line first. So the line is going to have a y-intercept of 5, because when x is 0, y is going to be 5. So right there. And its slope is -1. And so let's say at x equals 1, y is going to be equal to 4. At x equals 2, y is going to be equal to 3, and so on. So this is what the line looks like. Now we can graph the circle. We know that the radius of the circle is 5, because 25 equals r squared. And if you square root both sides to get r, you'll get 5 equals r. So we know the radius of the circle is 5, which means that these are all points on the graph. Is that -5? And it's centered at 0, 0. And so this is going to be the circle. Like that. So now we can see that the line intersects the circle at 2 points. It intersects right here and right here. This point is at 0, 5, and this point is at 5, 0.